I've got the 8903 on the bench this morning. I was using it last night and doing some different amplitude checks for an amplifier, and then suddenly noticed that there's something odd going with the outputs. When I set a voltage for the output of the generator, it wasn't necessarily what I was typing in. So I did a couple of other checks and I thought, oh, maybe the meter's reading wrong, so I connected the output of the generator to an RMS meter, and sure enough, if you step the frequency up in steps, it doesn't always change into the correct step. Like if you do 100 millivolt steps, you probably won't get a step of 100 millivolts, you'll get nothing, and then it'll be a big jump to a volt. So I've been fiddled about with it a bit more this morning, typed in 5 volts RMS, and I was getting about 6.8, and the amplifier was all clipped. So it looks to me like there's probably a digital processing error. Basically the digital to analog converter is not working correctly. So I forgot the top off it, and this thing has been working impeccably since I repaired it about 5-6 years ago. Had no problem with it at all. And to be honest with you, it might have been like this for a while. I don't tend to, once I set the amplitude level, I tend not to sweep the output of the amplitude, I just sweep the frequency, and that side of it's working fine. So I'm just going in here just to have a look at the stuff, and the first thing you do notice is the sort of things like these LEDs that are obviously 30 years old. They are incredibly dim, and I can't remember them ever being that dim. So I'm just going to go inside here and have a look at this. Is the power supply down here, and you can see these four green LEDs. No, I don't know if you can, it doesn't really show up very well in the camera, but the third one in is particularly dim. There we are. That's the plus 15 volt rail. So I'm going to just go through and check these rails and see if we can find out if these voltages are okay, and if they're within spec, we'll move on to trying to work out where the digital to analog conversion is, and have a look at that so we can see anything obviously wrong. But I wouldn't be surprised if it's like a shift register chips packed up, and these sort of faults are really difficult to find. So anyway, let me check the voltages first and see what we've got. Right, let's connect up to the meter. Let's have a look at the first rail, and the first rail should be, stick my hands on the main socket, so that's going to go down well. So it should be 5 volts, 5.12, that's good. This should be plus 12, 12.13, that's good. This should be plus 15, 14.72, it's a bit low. Minus 15, minus 15.15. So, suspicious of the plus 15 volt rail. I need to check the spec on that. It doesn't look like it's individually adjustable, it's all independent regulators, linear regulators. So I might need to change one of the regulators. So I'm going to have a look at that first in the circuit diagram to see what the specs are. Because we need to get certainly get that rail up higher if that is low, and then we can come back and then start looking at the fault, because it might be just that there's not enough voltage drive to turn the chips on properly. So let me investigate the voltage and we'll come back. I'm just going through this check here. This basically checks the amplifier outputs are correct. I don't think it is actually the amplifier itself, as I say. I think it's the selection of the amplifier's levels, or the attenuator maybe is messing around. So we've done this this point here where you're checking the test point and A3 test point 7, and basically you do a system reset. You specify a couple of ranges on the attenuators by putting in a special function here. Connect the input and output together. And then at test point 7 you should see 800 to 900 millivolts peak-to-peak waveform, approximately 1 millisecond, and that's what I was getting. That was absolutely fine. The next bit that seems to all go a bit awry is the next stage here. It says using the oscilloscope's vertical gain controls, otherwise take it out of calibration, adjust it for 5 divisions peak-to-peak deflection. Okay, so basically you move the waveform so it's covering 5 graduations on the vertical, and it says connect to A4 test point 8 amp 1, which is the other board up, and the peak-to-peak amplitude should be on the scope should be 2.4 to 2.6 divisions. Well, it's not quite 2.4, 2.6 is about 2, as you can see there. We're low on amplitude there, so that would suggest to me that this is sort of narrowing down the fault slightly. And it says, if faulty, see service sheet 5 and check attenuators 1 and amplifier 1. So I think yeah, we're looking at attenuator fault or an amplifier fault. I still think we're going to end up looking at a selection problem on the way the thing responds to different commands. One level it's okay, and it's capable of producing the output, it's just not programming properly. So let's go to this service sheet 5 and have a look through that. Right, I'm going to stop the fundamentals of the output of the generator just to try and work out where the fault lies. I think it's probably in like a FET switching attenuator, but I'm not too sure at the moment. This is just a guess on my part. So I'm reading service sheet 9, and service sheet 9 tells you to do the following thing. A5 test point 6 oscillator 1, which is on there, should have an amplitude of 1 millisecond, an amplitude of 8.3 to 8.7 volts peak to peak at 1 millisecond intervals. So we'll go 1 millivolts, 1 millisecond divisions. That looks good. Amplitude 2, 4, 6, 8 point, about 8.2, 8.3. So it's a little bit low, but it's just about in the bottom end of the spec. It says hints if the signal is faulty, see service sheet 8 and check oscillator tuning. Okay. So now it says connect your oscilloscope to A6 test point 6. So A6 test point 6. Where are we? Which is amp 1 again. Okay, and now it tells you to put some special commands into the unit. So key in 59.0 special function. Okay, then it tells you to enter 58.255. These are setting all levels. So 58.255 special function. Okay, let me just. Now we should see a level of 9.8 to 10.2 on that test point. 2, 4, 6, 8, 10.1, 10.1, 10.2. So that looks good. And it says hint, if the level is incorrect, but is between 4.98 and 10.2, continue with the following steps and determine the FET switch is working. Okay, well that is working at the moment, so I think the next step is to read on and see what I need to do next. Okay, if ascertained it's the first oscillator seems to be working okay, and its first stage attenuator also appears to be okay, and that's looking at test point 6 on the A6 board, which is amp 1, and the level doesn't change because that's supposed to be sort of like only a very fine adjustment, and well, that appears to be okay. If I move up to the next test point, which is test point 2, this is where we got the big error on, and let me just show you what I'm doing. So if I set as 0 dB, you see our levels here. Now you can see on the meter here, hopefully you can see on the meter here that it says 0 dB. So I'm just going to add 2 dB. Watch the scope, big gain, got 2.17 dB. I'll go 4 dB, 4.66, and it's jumped up miles. So it looks to me like the attenuator here isn't working correctly. So let's go 0 dB, just to check again, back to a 0 dB reference. Let's go minus 1 dB. Not enough. Let's go 0 dB. Okay, do this again, minus 1 dB. Minus 1 dB. 0.34. So there's something wrong with the fine tuning on the attenuator. One of the attenuator A, it looks like, has got a problem. So the next thing to do is go and have a quick look at visual inspection of that. I'm not sure if that's a relay or not, so I'm going to pop the board out and we'll have a look at that. We're looking at this point here, test point 1, and the level stays constant here, so I'm not concerned, that's doing anything odd. At this point here, though, test point 5, which is amp 2, the level's shifting about all over the place. Now, what there is here is this attenuator circuit here, which is switched by some sort of like hybrid IC, which instantly rings alarm bells. But it's also controlled by this, if you turn over the page here, this controller here, which is just a sort of generic Texas Instruments shift register or something. You might actually have one of those, and if that line's not being controlled correctly, that could cause the problem. Basically, these attenuators aren't being switched when they're meant to be, or one isn't being switched at all, and that could cause a problem. So before we sort of assume the worst, it could be this circuit here. I think I'm going to try and replace that shift register or whatever it is, and that chip is actually, so that's U6, and U6 is just here. This chip here, it's upside down I think, but it's not. It's an SN74 LS42. So I jumped forward ahead slightly and excuse me, check these attenuators here, and these are basically the 2.5, 5 and 7.5 dB steps. And if you actually step 2.5, 5 or 7.5 dB, the attenuation spot on, there's no problem at all. It's only when you put a finer adjustment in, then the levels are all incorrect. So I went back, and unfortunately what you're supposed to do on these is you're supposed to test them on an extender board and check the gate drives to these FETs here, and basically they switch in these various resistors and they act as an input attenuator. So it's fairly straightforward. And here's our sort of like logic chart here, and what we should see on each chart. So basically, if you see here, we enter, we start on Q21's gate, type in 58.127 special, and it should go -15 to the gate, or that equates to pin 9, IC9 pin 13. So there's all the logic going through there. Now you can see the ticks and the crosses I put here, and these are the ones that I'm getting good results on and bad results on. So 20, 21, 22 and 18, 21, 20 and 22 and 19 have all failed. So if you look at these transistors here, here's 21, and that goes to IC9. 20, that also goes to IC9 down here. Sorry, down here. So let's do that again. So 21 goes to IC9 here. I bet you can see a bit better now. Q20 is a gate, goes down to this IC9 again, this op amp here. The other one that failed was 22, which is here, and it comes down here and also goes to IC9. And the final one that failed was 19, which is here. Where are we? There it is, just there. So down pin 9, IC9 as well. All the other ones have passed. So therefore, we got two comparators on this board, and I strongly suggest that one of these comparators blow up. IC9's dead. IC8's obviously still working and attenuating the right levels at certain points, but because there's a combination of attenuators you need to click in and out to get the right level, one attenuator circuit isn't working, therefore the levels are jumping around all over the place. And that's sort of what you see when you're stepping through the frequencies. The levels are jumping all over the place because even though the coarse attenuator is working, the fine attenuator isn't working. You're not getting the 1 dB steps. So the next thing to do is try and track down what U9D, like U9 is, these op amps, and replace them with something hopefully in the workshop. Right, this is the IC that's suspect. It's an LM339, and I've actually got something better than that. I've got an LM139. LM139 is a mil-spec component. Not it's going to make any difference in a device like this, but I'm going to desolder this chip, replace this chip, and see if this fixes the problem. Okay, let's remove IC9. Now what I usually do with these chips is I cut the legs off them first, and this is the sort of easy way to do it because it's less damaging on the board if you're trying to pull a chip out and you're not sure which pin it is that's still connected. So I'm just going to go around and cut all the pins on the chip, snip them off the top of the board with a sharp pair of cutters. Get to them all, so I'm a bit further recessed than others. This is quite nice actually, because even though it's got the HP part number on it, to save me having to go and search the part number, I've managed to find the part number. It was actually in the actual manual, service manual. It sort of cross-references it to the LM part number, so it makes it easy to identify the chip. So there's the head of the chip off, and drop that off. Basically just a case of desoldering them now, and then they can just fall out on the floor. I'm going to just do do this over here because unfortunately the mains lead isn't very long on the soldering iron, so I'm getting the right chip. And the airline's fallen off this. Lost the vacuum. Okay, try again. I have no idea how long this fault's been here. It could have been here for a long time. It might have only just recently happened. As I say, it's very rarely I adjust the attenuator to such fine levels anyway. In theory, those pins should just fall out now. Never do, but there's plated through holes. So what you can do now, because you've basically loosened them all off, you should be able to just put heat one side of the other side of the board and just pull those pins out. So I'm just going to pull the pins out now. Try not to burn myself. That's one. Two. Three. Pretty best doing this with pliers actually, but because I'm a hard biker I don't feel pain. That's that line done. It's a much easier way of doing it. And it's much less likely damaging the board like this. Doing a bit of a bugger. Okay. Two more to go. There we go. So there the holes out of the board. You see the track's clear now. So I'm just going to wick off any excess solder and we'll put the new chip in. So I'm going to do that off camera. Okay, there's the chip I replaced just here. This one, resoldered that in. So let's see if this has fixed the problem. That'll be the moment of the truth, is to plug it in and see if it works. Okay, the easiest way to do this, to see if this proves the point, is to set our amplitude at 1 volt. Our frequency of 10 kHz, that's fine. Now what I'm going to do is I'm going to set a 0 dB reference point, so we're at 0 dB, and what I'm going to do is tell it to drop -1 dB. Now before it would drop sort of the wrong value, so let's try this. So amplitude -1 dB, -1 dB. Amplitude minus 5 dB, 4.98, that's correct, that's well within specs. Let's go back to 0 dB, amplitude 0 dB, excellent, amplitude 1 dB. So that's it, it's fixed. Took me longer than it should have done to find it, but I still found it. I'm pleased. I found the part I had actually was kicking around in a junk cupboard, which is the LM139 or 339 has failed. Basically, half the FETs weren't being switched. Back and running again. Whilst it's out and it's nice and warm in here, I think it's time to do. I might as well do a calibration on it because it hasn't been done for a while. Anyway, but thanks for watching, and more to come. Okay, we're not quite out of the woods yet. The attenuator is working correctly. I've just performed a calibration on it. It can't produce its full output without distortion. I'll just show you this now. If I type in an amplitude of 5 volts, this is the. So let's go 6 volts. Let's put it to its limit. You see that squaring off at the top of the waveform? Now that is being produced at the final stages of the output stage. If you look at the meter here, you can see on the meter on the front panel we've got 3.6% distortion at full drive, which is unacceptable. Should be still sort of 0.02%, less than that. So we've got a problem in the output stage. Just looking at the circuit diagram, if we look, let me just turn you, sorry I have to move you about to get you in view. We're looking at this point here. This amp 3, this signal here is clean, but when it comes up to this filter high, is very distorted. Now we've got sort of like a matching networks and things here, but after this we've got clamping diodes. So I'm wondering if I've damaged the front end somehow and maybe taken one of these diodes out, these back-to-back protection diodes. So I want to check these CR. It's clipping on the positive going slope. So when this becomes high, one of these is maybe leaky or maybe I don't know. Could be anything really. Could be leaky diode. The rail, the plus and minus 15 volt rail was slightly low, but not out of tolerance. So I don't think that's a headroom problem. I think it's more like a short or a leaky component on the output. So I'm just going to pop this AE6 board out again and have a look so we can check the diodes. Let me look at this clamping circuit here. So basically what we've got is a reference point here. So this point is held at ground, and they've got two 5 volt Zenas in series. So we've got about 10.2 volts biasing those diodes on, plus their forward conducting voltage. So 10, 11, 12 volts. Well, what happens is when it gets to that point, if the level goes beyond that point, it will clamp it to try and protect the amplifier, the input of the amplifier. Also prevents a bit of protection back upstream. It has got these fuses in line as well, but they're not going to be the best. So what I've done is I've checked these, first of all, these 4 silicon diodes, and they're fine. Just been through checking these, and VR4 is leaky. So what's happening is this reference voltage is low. So what's happening is this thing's clamping too early. So I need another 5 volt Zena to replace that one. That should free up that input. So I'm going to pull out VR4. It's only protection circuitry. It's not going to affect the way the unit works. It's there for protection. I can replace the diode at some point. So I'm going to remove VR4. And VR4, just in case you want to see it on the board, VR4 is this diode here. And let me just show you what I get when I put it on the meter. So one way round, it should act just basically like an open circuit, because you're checking it with only a couple of volts. You should have a this way you should have the diode junction. Well, we haven't. It's sort of like, it should be 0.6, 0.7 volts. And the other way, it should be open circuit. It should show nothing at all. It's the other way around, and it's the same. So that diode's failed. So let's lift that diode out and chuck the board back in and see if it clears this distortion problem. Right, remove that clamping diode, switch it on, see what we get. Now I'm just actually suddenly thinking about this. You know, I was saying the minus 15 volt was low. Of course, that diode's across the minus 15 volt. I wonder if that was pulling it down. So let's have a look at our levels now. So amplitude 6 volts, distortion, there we go, distortion's back to a sensible level. And now I'm going to do is have a lift you over just to have a look at the LEDs brighter. Oh, no, it's not, but I'm going to check the voltage. That could have been the problem, that diode was clamping the 15 volt rail down. I'm not sure if it would or not actually, but it certainly would have been dissipating more energy because that other, there's only had a 5 volt Zener in series. Excuse me whilst I walk around. Just check to see if our 5 volts has come up at all. 15 volts, sorry. So we're just measuring the 15 volts. I don't see the meter, but I'll read out what I'm getting. Nothing at the time. Oh, got 14.73. It's come up very slightly actually, but not a lot. So that wasn't the problem with that. But clearly we've cleared that distortion now. That's brilliant. I need to get a 5 volt Zener and pop it in. I might have one in the workshop, but quite a successful afternoon actually with this. Fixed the attenuator. I fixed that problem with the clamping on the output. So thanks for watching, and really is more to come.